All right, so according to my notes, we finished example 6 at the bottom of page 3. And so now we're moving on to page 4. So top of page 4, we have the conjugate zeros theorem that says let f of x be a polynomial function that has real coefficients, right? The emphasis is real coefficients, right? Coefficients are real numbers. If a plus bi is a complex zero function, then the conjugate of a plus bi, a minus bi, is also zero function. So when you have polynomials with real coefficients, the complex zeros of that polynomial function come in pairs. If you know one, you know the other just by taking the conjugate. Okay? So in example 7, we have to find a polynomial of degree 5 that has integer coefficients, which is real numbers, and zeros at x equals 1, x equals I, and x equals 2 plus I. And passes through the point in the coordinate plane. The graph passes through the point 0, 5 in the coordinate plane. You'll notice that's the y-intercept, right? The graph, the y-intercept of the graph of the polynomial. All right. So the degree of the polynomial n is equal to 5, okay? And it's integer coefficients and zeros at x equals 1, x equals I, and x equals 2 plus I, okay? So if there is, this is a complex zero, so given this is a zero of the polynomial, its conjugate is a zero of the polynomial, okay? So this complex number on the right can be written as 0 plus I. What's the conjugate of 0 plus I? 0 minus I, right? Which is just equal to minus I. So if x equals I is a zero of the polynomial, so is it x equals minus I. And then we're given x equals 2 plus I is a zero of the polynomial. So by the conjugate zeros theorem, 2 minus I also has to be a zero of the polynomial. So those are the 5 zeros of the polynomial. And then by the factor theorem, from page 1, top of page 1, says if x equals c is a zero of a polynomial function, then x minus c is a factor of that polynomial function. So if x equals 1 is a zero of the polynomial function, then x minus 1 is a factor of the polynomial function. Similar, x equals I is a zero, so x minus I is a factor. X equals minus I is a zero, so x plus I is a factor. And now over here, right, you guys subtract 2 and subtract I from both sides. And we get x minus 2 minus I is a factor. And here we subtract 2 and add I to both sides. We get x minus 2 plus I is a factor. Okay? So given we know the zeros, we know the factors from the factor theorem. Okay? Right, so these are the factors of our fifth degree polynomial. Okay? So now we can write out the polynomial in factored form because we know the 5 factors for a fifth degree polynomial. F of x is equal to, now it's going to have a leading coefficient, so leading coefficient we call A, and then we write out the factors. X minus 1 times x minus A times x plus A times x minus 2 minus I times x minus 2 plus I. So this is our factored polynomial of degree 5. Okay? Yes, ma'am.
Why would you not add a 5 if that's the y-intercept? Like plus 5 tacked on at the end.
Because this is the factored polynomial. If we expanded this out and wrote the polynomial as a times x to the fifth, a to the sub 5 times x to the fifth plus a sub 4 times x to the fourth. So then we got all the way out here, constant term, we have plus 5. This is factored. This is unfactored.
Got it.
Okay? There's difference, right? All right. So now we got to expand. So we're going to multiply x minus I times x plus I, and we're going to multiply these two factors. Well, you'll notice that this x minus I times x plus I is of the form a minus b times a plus b, right? And a minus b times a plus b is equal to what? A squared minus b squared, right? Difference of squares. So this is equal to a times x minus 1, right? A is equal to x in this case, and b is equal to I. So this is equal to x squared minus I squared. And now I'm going to do, in expanding this, I'm going to group the x minus 2's together, each of those factors, right? Just put parentheses around x minus 2. That doesn't change anything. It's still x minus 2 minus I and x minus 2 plus I. But now, when I put parentheses around the x minus 2, the product of these two factors is of the form a minus b times a plus b, where a is equal to x minus 2 and b is equal to I. Okay? And so when I multiply those out, I end up with a difference of squares. Okay? So we have x minus 2 squared minus I squared. Okay? And we got nested parentheses, right? So you have the same number of left-handed parentheses as right-handed parentheses. Well, what's I squared equal to? -1, right? So we have a times x minus 1 times x squared minus a -1. And then in the second parentheses, when I expand x minus 2 squared, right, that expands to x squared minus 4x plus 4, right? You do x minus 2 times x minus 2. So in this, inside these parentheses, I have x squared minus 4x plus 4. And then we have minus I squared, which is minus negative 1. Which is equal to a times x minus 1 times x squared plus 1, right? Minus a negative 1, same as plus 1. And then over here, minus a negative 1 is plus 1, 1 plus 4 is 5. I have x squared minus 4x plus 5. And you notice that there isn't I anywhere now, right? There's not an I to be found. Okay. So that's what f of x is equal to after we expand. And we're not going to expand all the way, but we've expanded enough, okay? And now we can figure out what a is equal to, okay? So we're given that the graph of the polynomial passes through the point 0, 5. Well, you should recognize that the point 0, 5 is the y-intercept, right? The x-coordinate is equal to 0. And what this says is f evaluated x equals 0, right, is equal to 5. And those function values and y values are the same. So, plugging in 0 in for x here, on the left and right hand side, we have f of 0 is equal to a times 0 minus 1 times 0 squared plus 1 times 0 squared minus 4 times 0 plus 5. Well, f of 0 is equal to 5. And then when you do the PEMDAS now, order of operation, but you got minus 1 times plus 1, which is minus 1. And this in parentheses is just equal to 5, so we have minus 1 times 5, which is negative 5. So we end up with minus 5a. And when I divide both sides by negative 5 and switch to 2 5s, or switch to 2 sides, we have a is equal to negative 1. So now I can put in negative 1 in for a here on the right hand side. And our factored polynomial is f of x is equal to negative 1 times x minus 1, which we don't write out the negative 1, we just use the minus sign, right? That's an invisible minus 1 there. So the negative of x minus 1 times x squared plus 1 times x squared minus 4x plus 5. So this is our 5th-degree polynomial. In factored form. All right, we could expand it if we want it completely in unfactored form. We'd have to continue to expand this. And so you can see there I is not anywhere. So this, if you were to expand this all the way, and there are no fractions anywhere. So if you were to completely expand this, right, you would have real integer coefficients. haven't expanded. Okay. Any questions on that? As you can see in factored form, there are no I doesn't show up anywhere, and all the numbers are integers. There are no fractions anywhere. Any questions on that? Okay. All right, so let's take a look at example 8. Verify that x equals minus I is a zero of the polynomial function and find all other zeros. So our polynomial function is f of x is equal to 4 times x to the 4th minus 8 times x cubed plus 9x squared minus 8x plus 5. So to verify that x equals minus I is a zero of the polynomial function, we put in minus I in for x to show that the right-hand side is equal to 0. So f of minus I is equal to 4 times minus I to the 4th minus 8 times minus I cubed plus 9 times minus I squared minus 8 times minus I plus 5. Okay? So let's just review for a second. I is equal to the square root of negative 1. I squared is equal to negative 1. I cubed is equal to negative I. And I to the 4th is equal to 1. Okay. Well, you notice we got to do negative I to the 4th, negative I cubed, negative I squared, negative I. Okay? So, minus I to the 4th. Now, the shorthand answer, a negative to an even power is equal to what? 1, right? So, but we can write that is negative 1 times I to the 4th, right? Excuse me, I'm doing this. This is supposed to be minus I to the 4th power. Okay? That's what we got to find here, minus I to the 4th power. And minus I is the same as negative 1 times I. And that's the same as minus 1 to the 4th power times I to the 4th power. And minus 1 to the 4th power is 1, and I to the 4th power is 1, so we end up with 1 times 1, which is 1, okay? So this is just equal to 1, okay? And then minus I cubed, the same as minus 1 times I cubed, which is equal to minus 1 cubed times I cubed. And minus 1 cubed, you know, is minus 1. or just minus, and I cubed is equal to minus I. So we have minus a minus I, which is just equal to I. Okay? Are you with me? So, this is equal to 4 times 1 minus 8 times I plus minus I squared is just going to be equal to I squared, and I squared is equal to negative 1. And then minus 8 times minus I is equal to 8I, right? Negative times negative is positive, and we just end up with 8 times I plus 5. So minus 8I plus 8I cancel, and we're left with 5 or 4 minus 9, which is negative 5, plus 5 is 0. So f of minus I is equal to 0. And so we verified that x equals minus I is a 0 of f of x. Okay? And if minus I is a 0, what else is a 0? What's the conjugate of minus I? Plus I, right? So x equals minus I, and x equals I are zeros of f of x. And we're instructed to find all the zeros of f of x, right? So we found 2 of them. Yes, sir.
Wait, why isn't I cubed negative?
Negative I cubed?
Yeah, why, he says equal to negative I, right?
Well, negative I cubed, negative I can be written as negative 1 times I. By the rules of exponents, this is equal to negative 1 cubed times I cubed. Negative 1 cubed is minus 1. And I cubed is minus I. So you got minus times a minus times I, which is plus I. Minus 1 cubed is really, right, it's just equal to minus 1. Maybe I should write it like that way. And I cubed equal to negative I is negative 1 times I. So you get negative 1 times negative 1, which is plus 1. Okay?
Yeah.
So maybe I should write it like that. Negative 1 times negative 1 times I is equal to I. Okay. All right. So if x equals minus I are zeros of the polynomial function, then it's true that x plus I and x minus I are factors of f of x by the factor theorem. Top's page 1, right? That we've alluded to already this morning. Okay. So, our polynomial f of x equals 4x to the 4th minus 8x cubed plus 9x squared minus 8x plus 5 can be factored into x plus I times x minus I, right? Times some unknown quotient, q of x, okay? Some unknown quotient, q of x. Well, when you FOIL x plus I times x minus I, you end up with x squared plus 1. So I do a lot of stuff on the side. X plus I times x minus I, you know, is the difference of squares. It's equal to x squared minus I squared, and I squared is equal to -1. So this just ends up being x squared plus 1 when you FOIL that. Okay. All right. Well, how do we find q of x? But venture guess. So here's our 4th degree polynomial, unfactored form, and it's equal to x squared plus 1 times q of x, right? So if I divide both sides by x squared plus 1, I have q of x is equal to 4x to the 4th minus 8x cubed plus 9x squared minus 8x plus 5 divided by x squared plus 1, right? Our unfactored 4th degree polynomial is equal to x squared plus 1 times q of x. So if I divide both sides of this equality by x squared plus 1, I get q of x is equal to 4th degree polynomial divided by x squared plus 1. How do I find q of x now? Can't do synthetic division because this is x squared. So what kind of division do we have to do? Long division. You know how to do that now, right? But homework's due tonight. So we have 4x to the 4th minus 8x cubed plus 9x squared minus 8x plus 5 divided by x squared plus 1. Now I'm not going to do the long division. We've already covered that. That homework's due tonight. I'm just giving you verify my long division. But when I did the long division, I got for the quotient 4x squared minus 8x plus 5. That's our q of x. That's this q of x over here. So to find the remaining two zeros, we set the quotient q of x equal to 0 and solve for x. So we set the quotient q of x, 4x squared minus 8x plus 5 equal to 0. And solve for x. Well, this doesn't factor. A is equal to 4, B is equal to -8, C is equal to 5. So you got to do the quadratic formula. X is equal to -b, so you got the negative of -8, plus or minus the square root of b squared minus 4 times a times c. Oops, I forgot to substitute. Minus 4 times a, which is 4, times c, which is 5, over 2 times a, which is 2 times 4. So negative of negative 8 is plus 8. And the determinant is equal to minus 16. You can verify my math. And square root of minus 16, square root of 16 is 4. So square root of minus 16 is 4i. So x is equal to 8 plus or minus 4i over 8. And you know, division does not do addition and subtraction, so each of those terms have to be divided by 8. So you have 8 over 8 plus or minus 4i over 8, which is x is equal to 1 plus or minus 1/2 I in standard form. Okay. So I erased it already, but the first two zeros of that this polynomial function were minus I and plus I. The last two zeros are 1 plus 1/2 I and 1 minus 1/2 I. So x equal 1 plus 1/2 I, and x equals 1 minus 1/2 I. And let's write out the other two as well. And x equals minus I, and x equals I are zeros. Of f of x. Okay, those are the 4 zeros. Any questions on that? Okay. All right, let's take a look at example 9. One solution to the equation x to the 4th minus 6x cubed plus 14x squared minus 22x plus 5 equals 0 is the complex number x equals 1 plus 2i. Determine all the solutions to this equation. Well, if one solution is 1 plus 2i, what's another solution?
1 minus 2i.
There you go. Complex zeros theorem. Okay. So example 9, we know x equals 1 plus 2i is a solution. So, right, which means 1 plus 2i is a 0 on the left-hand side, right? Put in 1 plus 2i for x on the left-hand side and simplify, left-hand side will equal 0. So if 1 plus 2i works, then 1 minus 2i works. Okay? So these are two zeros, and they are two solutions to that equation. Okay? Well, by the factor theorem, if x equals 1 plus 2i is a 0, then x minus 1 minus 2i is a factor of that 4th degree polynomial. And x minus 1 plus 2i is a factor. Okay. So those are two factors of the 4th degree polynomial. So our fourth degree polynomial, x to the fourth minus 6x cubed plus 14x squared minus 22x plus 5 is equal to the factor x minus 1 minus 2y times x minus 1 plus 2y, right? Those are two factors of this fourth degree polynomial, times some unknown quotient q of x. Okay. Well, I'm going to, in expanding and multiplying out these two factors, I'm going to group the x minus 1 inside each factor. Right? Put parentheses around the x minus 1. And now you can see that this factor here is of the form a minus b, and this factor is of the form a plus b. A is equal to x minus 1, b is equal to 2i. We've already done this earlier today. And you know when you multiply that out, you get a squared minus b squared, right? So this is equal to, when you multiply these two factors, x minus 1 squared minus 4i squared times q of x, which we don't know what it is. Well, you know I squared is equal to negative 1. And so x minus 1 squared is equal to x squared minus 2x plus 1. And we have minus 4 times the negative 1 times the unknown quotient q of x. And then minus 4 times minus 1 is 4, and 4 plus 1 is 5. So this is equal to x squared minus 2x plus 5 times the unknown quotient q of x. So what's q of x equal to? This fourth degree polynomial divided by this quadratic is equal to q of x. Q of x is equal to our fourth degree polynomial divided by x squared minus 2x plus 5. So again, you got to do the long division. X squared minus 2x plus 5. You have to divide that into the fourth degree polynomial. X to the fourth minus 6x cubed plus 14x squared minus 22x plus 5. What's the quotient? So instead of rushing through this, you find the quotient for class on Wednesday. And then you set that quotient equal to 0 and solve for x to get the remaining two solutions to that equation. Okay? And we'll compare answers on Wednesday. Okay? So we will finish this on Wednesday, and then this homework will be due Thursday, and I plan to release it today so that you can get started.
So that's 29.